Day 257 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems, and today we have question number 52 in Queens 2. The difficulty level is hard, but don't even worry because you already know we're going to keep the solution as simple and easy to understand for everyone, no matter what level of your programming journey you may be on. So let's get into the question. Question says, the n queens puzzle is the problem of placing n queens on an n by n chessboard such that no two queens can attack each other. Given an integer n, return the number of distinct solutions to the n queens puzzle. So let's break that down by looking at example 1. In example 1, we have the input n equals 4, the output equals 2. Explanation says there are two distinct solutions to the 4 queens puzzle as shown. So let's break example 1 down a little bit further to see exactly what it is that they're doing, right? So in this case, n equals 4. That means that we're going to have 4 queens that we're going to have to place on an n by n chessboard. So in this case, n by n is always going to be a square, but we don't know what n is going to be at the time. In this example, n is 4, so a 4 by 4 chessboard, and we have 4 queens that we have to place on that chessboard. And if you know how chess works, you know the queens can move any direction. They can move left to right, they can move up and down, and they can move diagonal as many spaces as they want. So we want to find a way that we can place 4 queens because n equals 4 on a 4 by 4 chessboard because n equals 4 without any of the queens being in position to attack each other. So as you can see, for this, we can start here. So as you can see for this queen, it cannot attack any other queens by going left or right or up or down or diagonally. Same goes for this queen. There's no queens in its attacking path. Same for this queen. There's no other queens in its attacking path. And same for this queen. There's no other queens in its attacking path. And the same thing applies to this chessboard or this n by n board as well, because there are two distinct solutions. So this is one solution and this is the other solution, and we just want to return the count of the number of solutions, distinct solutions that we can create. And in this case, the example was 2 because these are the only 2 solutions that we can create where the queens will not be able to attack each other on a 4 by 4 chessboard with 4 queens. So that's all we're trying to do. We're just trying to place all the 4 or all the n queens on the n by n chessboard without the queens being able to attack each other in any which direction. So let's look at example 2 where it might throw a little trick our way where there's only one queen, meaning there's only one square, and the output will be 1 because there's only one solution. If there's only one square, then there's only one place we can put a queen, and there's no other ways there's no ifs, ands, and buts about it, right? So that's how the question works. And now that we understand how the question works, let's get into the fun part, the actual solution. But before we get into the solution, y'all, don't forget, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, don't forget to like, comment, and subscribe. Now, excuse me, y'all, let's get into it, right? So the first thing we're going to need to do is we're going to need to create a variable that's going to keep the count of the solutions, right? So that's simple. All we have to do is create a variable. We're going to say var, we call it res, and we'll just set that equal to 0 just to start. And that is going to keep track of the solutions that we found, right? Next, we need to create a stack which will implement a depth first search with a D, depth with the D as in dog, first search for us, right? So in order to do that, we are going to create a tuple, right? So each element in the stack is going to be a tuple. So to do that, we're going to declare a variable. So we're going to say var, we'll call it stack, and we're going to set it equal to, we're going to open up the square brackets, and it's going to, then we're going to open up the parentheses for the tuple, and we're going to say the first element is going to be the current state of the board, right? So an array where row I indicates the column of the queen in row I, right? So in order to do that, we're just going to say array. First thing we're going to say array, open up the parentheses again. We're going to say repeating, colon, 0. Then we're going to say count, colon, n, right? And the second element is the current row index we are working on. Then we're just going to come outside of that tuple and we're going to say comma 0, just like that, right? Now we need to find a way to continue until the stack is empty, meaning all possible configurations have been processed. So to do that, we could just use a while loop. We're going to say, we're going to say while exclamation point stack dot is empty, which means while stack is not empty. We're going to open up the brackets. And now let's get into it. Now, the first thing, I'm trying to think how we should do this. Well, first thing we can do is we need to create a variable that will pop the last element from the stack for processing when we want to process it. But in order to do that, we could just we could say var, var, we could call it cur, then we could set that equal to, not cur for current, set that equal to stack, then we'll just say dot remove, remove last, just like so. Then we put the parentheses right there. Now we need to keep track of the current board state. So in order to do that, we could just declare another variable. We could call that row, and we could set that to cur.0. And now we need to keep track of the current row index. So in order to do that, we just declare another variable. We could call that idx, and we'll set that equal to cur.1. Now, if all the rows have been filled, that means a valid solution has been found, and we need to handle that, right? So in order to do that, we'll just say if idx equals row.count, row.count. What that means is all the rows have been filled. So now what we need to do is we need to increment the solution counter, which is res that we made up here, right? So we're going to say res plus equals 1. Then we could just say continue, so we move to the next state in the stack. So we just come down here and we say continue. Now we're not done yet. We need to create our helper function, right? We still need to create our helper function that will help us with our DFS. So in order to do that, we just come down here and we are going to say func, we could call it detect. We could say func, func, call it detect. So func detect, we're going to open up the parentheses, and it's going to be, we're going to say underscore I, colon, that's going to be an integer, and it's going to return a Boolean for us. Then we're going to open up the brackets. Now we need to start checking from the previous row. So in order to do that, we're going to say declare a variable. We're going to call that idx, and we're going to set that equal to I minus 1. Now we need to loop through all the previous rows to check for any conflicts, right? So remember, like if a queen was right here, that'd be a conflict because that means the queens can attack each other. That's not what we want. So we need to handle that and check for that. So in order to do that, we're going to say while idx is greater, idx is greater than or equal to 0. We're going to open up the brackets. And then we are going to say let LHS equal row square bracket idx. And that's going to be the column of the queen in the previous row. Now we need the column of the queen in the current row, right? So in order to do that, we're just going to say let RHS equal row square bracket I. Boom. Now we need to handle we need to see what to do if a conflict does occur, right? Meaning like we have two queens that are in the same column or two queens that are on the same diagonal, right? So in order to do that, we're going to say if LHS equals RHS, what that is going to do, that means two queens are in the same column. And then we're going to say or ABS, open up the parentheses, LHS minus RHS, come outside the parentheses, equal sign, open up more parentheses, I minus IDX. That means that two queens are on the same diagonal, so that we don't want either R. So to handle that, we're going to open up the brackets, and we could just say return true, meaning a conflict was detected. And then we come down here underneath that, and we can say IDX minus equals 1. We could decrement it by 1, meaning we're going to just move to the previous row. Boom. Now, just in case no conflict is detected, we could just come down here and we can say return false. But we're not done yet because we still need to call this detect helper function that we just created. So in order to do that, we're going to come back up here, and we need to iterate through all of the columns in the current row to place a queen, right? So we're going to iterate through all of the columns, right? Columns going up and down in each current row. So in this row, we're going to check all the columns. Then in this row, we're going to check all the columns. Then this row, we're going to check all the columns. And then last row, we're going to check all the columns, right? So in order to do that, we are going to say for I, excuse me, y'all, come right here. We're going to say for I in 0 up to n. We're going to open up the brackets, and we are going to say row square bracket IDX is equal to I. And that's going to place the queen in column I of the current row. Now, we're not done yet because we still need to call this helper function, remember? But we're going to call it in this for loop. So we're going to say, excuse me, let's clean that up. We're going to say, excuse me, y'all. We're going to say if exclamation point detect, which is our helper function we were looking for, if exclamation point detect, open up the parentheses, IDX. If this placement does not cause any conflicts, we're going to push the updated state onto the stack. So we're just going to come right here. We're going to open up the brackets, and we are going to say stack dot append, open up the parentheses, row, comma, IDX plus 1. Boom. But we're not done yet, y'all. We're almost there because we still need to return the total number of solutions found. So in order to do that, we could just come down here, come right here, and we could just say return res. Boom. So let's run this, see how it runs. Hopefully it runs how it's supposed to. Okay, we got some typos. Let's see. Line 5, it says must have consistent white space on both sides, res. So hold on now, y'all. The question is, where is the inconsistent white space? Oh, sorry, y'all, right here. I'm about to say what's going on, y'all. All right, let's run it again, see how it runs. Let's run it again. Okay. Instant method append line 21. Let's check out line 21. So let's see. It says instant method append expects a single parameter array of integers. So let's see what's going on here. It says if I, let me see, if, my bad y'all. Is it something with the stack? Did we create the stack wrong? No, the stack looking good. So what's going on here, y'all? It says stack. Oh, okay. I see what's going on here. This is a tuple, so it should be parentheses inside of parentheses. We need to pass in the tuple instead of just passing in how we pass it in. So now let's run it and see. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted. Sorry about that. Thanks for sticking around with me, though. Ooh, and look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Those some good numbers right there. Those are some good numbers. So before we leave, y'all, get one more look at the code. One more look at the code. Read it, learn it, love it, memorize it, internalize it. Do whatever you have to do so you understand what's going on in this solution. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.